So here at Energy Solutions, we were contacted by a customer with a Kingspan airsource heat pump unit just before lockdown, as he had no heating or hot water. So we were asked to go out and investigate. It turns out we actually had to rip the unit out and install with a brand new replacement Mitsubishi Ecodan unit. And here is how we got on.
Here we are on day one of starting work on replacing the Kingspan unit. I was previously called out to attend site because the unit wasn't running properly and the customer had no hot water or heating. As you can see from the internals of the unit, nothing looks too untoward as to what would cause the performance issues. The compressor does run, but as you can see, due to the condition of the unit and the fact that these units are no longer supported by the manufacturer, we've decided to replace it with a soon to arrive Mitsubishi Ecodan product. The original installation was fitted with a particle filter, but only a particle filter, not a magnetic one, which you'll see later. So that's going to get changed out for a TF1 supplied by Mitsubishi as part of the overall installation package. So I've cracked my flushing machine out, hooked it all up to the original flexible hoses, so just going to give it a once round with the flushing machine. As you can see, the system water isn't that dirty, so by the time I flush this through, put some cleaning chemicals in it, we should all be good to go later on. So here we are in the cylinder cupboard, a fairly bulk standard unvented cylinder. We've got the two expansion vessels at the top, we've got the pressure gauge there, filling loop, pressure relief valve and temperature relief valve as well. Big circulation pump. This looks like it's a little bit of a leak, but apart from that it's all fairly standard. So probably the first job of today will be to start unwiring all of the electrics and reconfiguring what was a fairly complicated third-party controlled Kingspan unit and converting that over to the Ecodan system where so here we are, we've got the FTC5 securely screwed to the wall. I've now wired in the relay for the immersion heater, separate power supply for the immersion heater, the power supply for the FTC5 and the comms cable that will go back to the outside unit. This way, whatever happens today, now by the time I go home, the customer will at least be able to have hot water, which they haven't had for the last month, via the immersion heater that's controlled directly by the FTC5. Next job is to start putting in all of the control wiring for the pumps and valves for the heating system. So here we are, wrapped up on the job. The unit's running nicely in heating mode downstairs, all set up in weather compensation, done all of the wiring and all set up with all of the relevant dip switches, flushed it full of glycol, and it's good to go for a handover to the client.